Hello, dear students. Good afternoon. Good afternoon to one and all. So, can you all able to see me? Am I visible and audible? Yeah, good afternoon, Karul. Good afternoon. So, am I visible and audible to all of you? Can you all see the screen? Yes. Okay, okay then. Okay, then let's start with the class. So today we may complete this hydrocarbons. Okay. So today will be the last class for hydrocarbons. So yesterday we have discussed about the aromatic compounds, aromatic hydrocarbons, and in that we have discussed the preparation of benzene and some examples of aromatic compounds we have discussed, and we have discussed about the stability, resonance of benzene, right? So today we will discuss the properties of benzene. So moving on to the properties, we do have two different properties, right? One is physical properties and the other one is chemical properties. So first, let us discuss the physical properties of benzene and then we will move on to the chemical properties. So coming to the point, the first property that we are going to see is about the polarity. So aromatic compounds, that is the benzene also contains only carbon and hydrogen in it, right? So again, the system is non-polar in nature. So alkenes and alkynes, aromatic hydrocarbons are also non-polar in nature. Okay, since we have carbon and hydrogen, the electronegativity difference between them is very, very less, so they are non-polar. And usually they are colorless solids. Yeah, good afternoon, Swati. Good afternoon. Yeah, they are colorless liquids or they are colorless solids. So this is the physical nature of it. And since they possess this aroma, they have the pleasant smelling, right? So they possess this pleasant characteristic odor. This we have already discussed yesterday. And coming to the solubility point of view, they are immiscible with water, but they are soluble in organic solvents. Okay, same as that of alkanes. Yeah, one more point is left out. That is the fourth point is about the naphthalene. So you all would be knowing this, no? Naphthalene balls, they are used in toilets and for the preservation of cloths in the bureau we used to keep, right? So that naphthalene ball, which is giving the pleasant smell, and it is used in the toilets, which is nothing but the aromatic thing. The two benzene rings fused together to give that naphthalene compound. So that is being used in our daily life. So they have the unique smell, that is unique aroma, and they have the moth repellent property also. Okay, so they have the moth is nothing but the insects, right? They have that insect repellent property. So that's why we are using this in toilets, and we are using this for the preservation of cloths in our homes. Got it? So these are the general physical properties of aromatic compounds. Now moving on to the very important topic, that is the chemical properties. Generally, all the aromatic compounds, that is arenes, they give electrophilic substitution reactions. Okay, very, very important for your whole organic chemistry. Okay, now this under special conditions, aromatic compounds can also undergo, last slide you need, yeah. Yes, Swati, just take it down. Have you noted? If you have noted it down, just let me know. I will move on to the next slide. Swati, can we move on to the next slide? Yes, finished. Okay, okay. Good. So coming to this, now under special conditions, all the arenes can also undergo addition and oxidation reactions. So these two type of reaction we will discuss later. Okay, addition and oxidation reactions are also there in this lesson that we will discuss at last. Now we will concentrate on the electrophilic substitution reactions. Okay. So some of the common electrophilic substitution reactions of arenes are nitration, halogenation, sulfonation, Friedel-Crafts alkylation, and Friedel-Crafts acylation. Okay. So these 5 electrophilic substitution reactions are very, very important. Okay. So these 5 reactions we are going to discuss here for benzene. So how does the reaction occur? So what is the mechanism? So what is happening? So we are taking an electrophile and we are substituting it in the benzene. So one of the hydrogen from the benzene ring is substituted by an electrophile. So who are electrophiles? Electrophiles are positively charged species. Okay. So the positively charged species that we are getting from these 5 type of reaction. So that is substituting one of the hydrogen from the benzene. So how many hydrogen we are having in the benzene? 6, right? So one of the hydrogen is substituted by the electrophile. So let me show the picture. So this is the benzene. So this is our benzene part. C6H6. Each carbon contains one hydrogen. Okay. Now this electrophile is coming and coming near this benzene, and one of the double bond will go and attack that electrophile. Okay, it will come and attack because the pi bonds are electron rich species. So electrophile is an electron deficient species. So the electron rich comes and attacks the electron deficient system. Okay, when it attacks this electrophile, one of the hydrogen is going out as H plus, and that hydrogen is replaced by the electrophile. So this is how electrophilic substitution occurs in benzene. This is the mechanism. Okay. Now let us discuss one by one. So first let us start with nitration. So for nitration, what I have to do? I have to take the benzene. So let us take this benzene. Let us take this benzene. And the nitrating mixture that we have to take for nitration is concentrated sulfuric acid and concentrated nitric acid. So this is the nitrating mixture. This is the nitrating mixture. And we have to heat this thing. We have to heat this nitrating mixture with benzene. And from this mixture, we will get NO2 plus electrophile. So this is the electrophile that we get from the nitrating mixture. And this electrophile will go and substitute one of the hydrogen from the benzene ring, and we will get the nitrobenzene as the product with the release of H2. Okay, so this is the main reaction. Now, how we are getting this electrophile from this mixture? So that we need to know, right? We need to know the generation of electrophile from the nitrating mixture. So that I will show you, the generation of electrophile. So first, yeah, we are taking both the compounds. So this is your sulfuric acid and this is the nitric acid. Okay. And here sulfuric acid is acting as an acid. Sulfuric acid is acting as an acid, and the nitric acid is acting as a base. Nitric acid is acting as a base. So what is the role of the base? Base will go and attack the hydrogen from the acid. So here is the electron rich part in the base. So these electrons, one of the electron pair of oxygen, it will go and attack the hydrogen from the acid, and it will bring that hydrogen towards itself, and the protonated nitric acid is formed, and this electron, this shared pair of electron is moving towards the oxygen. So what we are getting? We are getting HSO4 minus ion. We are getting HSO4 minus ion from the system. Okay. Now this protonated nitric acid, it is unstable. It is a positively charged species, right? So this protonated nitric acid is unstable in nature. So what happens here? The bond between the oxygen and nitrogen, it is the electrons present in that bond is going towards the oxygen, and it is going out as H2O with the release of NO2 plus. So all the electrons which are present here in this bond is moving towards the oxygen, right? So nitrogen is donating its electron. So nitrogen is getting the positive charge, and we are getting this NO2 plus nitronium ion like this, and this is the electrophile which is getting substituted there in the benzene. Okay, this is the electrophile. Got it? So this is the generation of electrophile. And here, one thing is very important. So in the question, they may ask which among the following compound is acting as an acid among sulfuric acid and nitric acid? Okay. So if they ask any question like that, so you need to know that nitric acid is a base and sulfuric acid is an acid here. Got it? So this is one of the very important point we have to keep in mind from this, and we need to know the electrophile formula that is being generated from this, and that's it. Okay, nitrating mixture, you know. So this is the nitration reaction. So any doubt? Any doubt you have from this? Shall we go with the second reaction? No? No doubt. Okay, okay. Shall we go with the next line? Yes? Okay. Fine. So the next reaction is halogenation. So again, take the benzene. Now we have to use halogenating agent, right? The halogenating agents are chlorine in presence of anhydrous AlCl3. So this is the halogenating reagent. And from this reagent, we have to get an electrophile, right? So that is Cl plus. Cl plus electrophile is generated from this mixture, and that is getting substituted to give the chlorobenzene with the release of HCl. Now, how this Cl plus is generating? What is the generation of the Cl plus? How it is getting generated? It is very easy. So in the previous case, we have seen two steps, right? So here within a single step, we will get the electrophile. So first, let us take this chlorine molecule. Let us take this chlorine molecule, Cl bond Cl. And with this anhydrous AlCl3 is reacting. Okay. Now, this anhydrous AlCl3 is an electron deficient species. It is an electron deficient species. So, the electron pair that is between this chlorine, they are coming with its electron. One of the chlorine is coming with its shared pair of electron and forming the bond with aluminium. Okay. Now, this chlorine is left with no electron. So, it is becoming a Cl plus, and AlCl3 is getting converted into AlCl4 minus. Aluminium is gaining the electron with one chlorine, right? So, it is becoming as AlCl4 minus with the Cl plus electrophile. So, this is the electrophile. Okay, this is how we are getting Cl plus electrophile. Got it? So, you need to know the halogenating mixture and the electrophile that is being generated. Okay. So, shall we go with the third reaction? So, the first is nitration and the second one is halogenation. Yes, Hashira. Okay. So, third, we will move on to sulfonation. So, take the benzene again. Now, the sulfonating reagent. Sulfonating reagent is very easy. Only one reagent. Concentrated sulfuric acid is a sulfonating reagent. Then we have to heat it. That's all. Now, this sulfuric acid here, if you see, it is called as fuming sulfuric acid. So, why it is called as fuming sulfuric acid? So, we are getting this H2SO4 from H2S2O7, which is called as oleum. This is called as oleum. Okay. Now, this is present as H2SO4 dot SO3. Okay. H2S2O7. Got it? Now, this sulfur trioxide is a gas, right? So, it will produce the fumes. Now, this H2SO4 part, from this H2SO4 part, we are getting the electrophile. And that electrophile is SO3H+. SO3H+. Okay, since the sulfur trioxide is producing the fumes, we are calling this as fuming sulfuric acid. So, that is getting generated from this oleum molecule. Okay. So, now this electrophile will go and substitute one of the hydrogen and it will give benzene sulfonic acid. SO3H is sulfonic acid. When it is substituted in benzene, it is benzene sulfonic acid, and H2O is the byproduct. Okay. So, this is sulfonation. Now, next we will go with the fourth reaction. Shall we go with the fourth reaction? So, have you all noted down this? Third, sulfonation. Yes or no? Yes. Very good. Okay. Okay. So, the fourth reaction is Friedel-Crafts alkylation. Friedel-Crafts is the name of the scientist, and he is doing the alkylation on benzene. Now, who is that alkylating agent? We need to know the alkylating reagent, right? So it is the alkyl halide with anhydrous AlCl3. Alkyl halide with anhydrous AlCl3 is the alkylating agent. Okay. Now, here, this is the mixture, and from this, an electrophile, alkyl electrophile is getting generated. R is the alkyl group. R is the letter we use to define the alkyl group, right? So that alkyl group will come and substitute in the benzene, and it will produce alkyl benzene with the HX. Now, how this R plus, that is alkyl electrophile, is getting generated? So that let us see now. It is same as that of, more or less same as that of halogenation reaction. So you have to take the alkyl halide first. So X is the halogen. It can be chlorine or bromine. In most of the case, it will be chlorine only. Okay. So that is reacting with AlCl3. So now the bonded electron is going with aluminium, and R plus and AlCl4 minus is generated. Now this R plus is the carbocation. Mostly alkyl groups are methyl, ethyl, propyl, right? So if we are having CH3Cl, and when it is treated with AlCl3, what we will get? We will get CH3 plus and AlCl4 minus, right? So this is mostly the positive charge will be on the carbon. So it is called as carbocation, and that is the electrophile that is being generated. Okay. So in some cases, the rearrangement occurs. So in case of methyl, ethyl, we don't find any kind of rearrangement. So when we go with the propyl, rearrangement occurs. So that I will show you in the next slide. Okay. So that rearrangement is happening because of the formation of the more stable carbocation. Okay. For that purpose, the rearrangement occurs, that we will see in the next slide. Okay. So the carbocation will undergo rearrangement before attacking on benzene in some cases. Now coming to the fifth reaction, that is Friedel-Crafts acylation, we have to take the benzene. Instead of alkyl halide, take acyl halide. Now what is the formula for acyl halide? CH3CO. The CH3CO group is called as acyl group. Okay. Or acetyl group. Both are same. Acyl chloride or acetyl chloride. Both are same. It is treated with anhydrous AlCl3 again. Now these are the acylating agent. Now from this acylating mixture, CH3CO plus electrophile will be generated, and it will go and attack the benzene. Okay. If it goes and attacks, we are getting acetophenone and HCl is coming out. Now how the CH3CO is getting generated? So take the acyl halide, that is acetyl chloride first, and treat it with AlCl3. In the same way, Cl minus will go with aluminium, leaving the CH3CO plus as an electrophile. Okay, so this is the electrophile. Got it? So we have seen 5 types of reaction, and in all those 5 types, just study or keep in mind the reaction mixture. Okay, electrophilic reagents you have to keep in mind, and the electrophile you have to know. Okay, that's all about these 5 reactions. Very easy reaction. At the end, I will summarize all these 5 reactions for you. Okay, so it will be very easy for you to memorize. Now we will go with one question. So let us try to solve one question. Write the major product of the following reaction. Write the major product. What could be the major product? So as I have already told you, so what is the type of reaction? So can anyone name this reaction? What is this? Whether it is nitration or halogenation or Friedel-Crafts alkylation or acylation or sulfonation. What type of reaction it is? Can you tell me by seeing the reagent? Can any one of you give a try for this? What is the type? We have studied 5 types of reactions, right? Just look into the reagents. Friedel-Crafts acylation. You are coming close to the point, but it is not acylation. Acylation means the system should contain C double bond O in it. Okay, Aisha. The system should contain R C double bond O. So here we are not having double bond, right? We are having only the R group and halide. So what is the name of the reaction? Friedel-Crafts alkylation. This is Friedel-Crafts alkylation reaction. Okay, very good, very good. Yeah, it is alkylation. Now, two different products we will get here. So we have to find out the major product. I told you that rearrangement, no, that concept I will explain you here with this example. So what could be the product? So first we have to generate the electrophile. Now take the propyl chloride and treat it with AlCl3. The electron pair will go with the AlCl3. Okay, and we will get a carbocation. We will get an alkyl carbocation. Now this carbocation is a primary carbocation. This carbocation is a primary carbocation. Since since the positive charge is on CH2, it is primary, right? So primary carbocation is less stable compared to secondary and tertiary. So this concept we know from the GOC lesson, right? Now what happens? 1,2 hydride shift. 1,2 hydride shift occurs. So this is called as rearrangement. This is called as rearrangement. Now how this 1,2 hydride? So what is meant by hydride? Hydride means H minus. Okay. So let me draw the structure like this. CH3, CH2, CH3, CH2, CH2 plus. So this is the primary carbocation. Now between this first carbon and second carbon, H minus hydride is going to get shifted. So take this H minus with its electron and shift this to this carbon. So what you will get? We will get a CH3 and CH plus. Now this carbon has donated its electron to this hydrogen, no? So you have to take that. And here already 2 hydrogens are there. Now 1 hydrogen is shifted. So we are getting CH3. Okay. So what is this? Now the positive charge is on CH. If the positive charge is on CH, it is called a secondary carbocation. If it is on CH2, it is primary. If it is on CH, it is secondary. If it is on C, it is tertiary. Secondary carbocations are more stable than primary carbocation. Okay, so for this stability purpose, this rearrangement, hydrogen rearrangement is happening here. And this shift is called as 1,2 hydride shift. Okay, so it is formed and it is more stable. And now this more stable carbocation will go and attack the benzene ring. If it goes and attacks the benzene ring, what we will get? We will get this product, right? If it goes and attacks the benzene ring, we will get, this is the benzene ring. And now the secondary carbocation is attacking the benzene ring to give this product. So this is the major product. We also get one more product, that is minor. So what is that? So primary carbocation will go and attack the benzene. So that product is also possible. So the formula will be like this. CH2 will go and attack. So we will get CH2, CH2 and CH3. So this is also formed, but this is minor. Since it is formed from the less stable carbocation, so it is minor. And this is formed from the more stable carbocation, so it is major. Got it? So what is the name of this major product? What is the name of this major product? This is N-propyl and this is isopropyl, right? So this is N-propyl benzene. The name of the minor product is N-propyl benzene and the name of the major product is isopropyl benzene. Isopropyl benzene. Got it? Is this concept clear to all of you? Yes or no? Just let me know if this concept is clear. If this rearrangement part is clear, just let me know in the chat box. Major product will be from the more stable system. That is a concept. Okay. So for 1 carbon and 2 carbon system, we will not have any issues because no such rearrangement is possible for them. Okay. Even if you rearrange, you will get the same thing for the methyl and the ethyl. When you come to propyl, you have to do this rearrangement because we have two different profiles, right? One is N profile and isopropyl. So for that system, for that purpose, we are doing this. So this is how we are getting the major product. This is one of the very important concept you have to know. Good. I hope this is clear to all of you. Isopropyl benzene is also called as cumene. It is also called as cumene. The other name for isopropyl benzene is cumene. Okay. So these are the electrophilic 5 important electrophilic substitution reactions you need to keep in mind. Now next we will go with the influence, the directive influence of substituents during electrophilic aromatic substitution reaction. Let us see the influence of substituents. So far we have studied with only benzene, right? So in benzene we have did the reaction. Now let us see if the benzene contains any substituent in it, how the electrophilic substitution is going to happen. Okay. So let me take the ortho-para directing groups first, and then we will discuss about the meta-directing group. So you all know what is ortho-para meta, right? Yes or no? So what is ortho? So okay, let me take this structure. So now OH is the group. OH is the group which is there on the benzene ring. If you're having any group adjacent to it, if any group is substituted here, then it is ortho substituted. And if anything is substituted here, then we can say these two groups are meta substituted. And if you're having any substitution here, then we can say these two are para substituted. Okay. Ortho means adjacent, meta means alternative, para means opposite. Okay. Good. Good, Shamila. Yes. So let us discuss the ortho-para directing groups first. So I have taken an phenol. Okay. And let us study the resonance that is happening in phenol. So how does the resonance occurs? The electron pair, one of the electron pair is getting shifted to carbon and oxygen, and the electron which is there, the pi bond electron is getting shifted toward the carbon. So we are getting a structure like this. Okay. Now what happens? Now this negative charge, the electron will come here and the electron will shift it here to give this third structure. Now again what happens? The negative charge will go there and the electron will get shifted like this to give the structure, and again at last the negative charge will move towards the ring, and the carbon oxygen double bond, that electron will go towards the oxygen to give the fifth structure. Okay. So totally we have 5 resonance structure for phenol. Okay. Now when you see here, this OH is donating. This OH is donating the electrons to the ring. Okay. So this OH group is called as electron donating group. OH is called as electron donating group. And this electron donating group is increasing the electron density at ortho and para position. Right. You see here, all the negative charge, it is going and getting delocalized in ortho and para position. Right. So the electron density on ortho and para position is more. Now, if we want to do the electrophilic substitution, we know that electrophiles are electron deficient. Electrophiles are electron deficient species. They are positively charged species. So they will try to, positively charged species will try to prefer the negative side. Right. Only the plus reacts with minus. No. So what happens here? So that electrophile will try to prefer this ortho and para position. So the electrophilic substitution will occur at ortho and para position. Got it? So now what you have to keep in mind is, if an electron donating group is there on the benzene ring, the incoming electrophile have to go to the ortho and para side. That's all. Okay. If electron donating group is there on the ring, substitute the electrophile in the ortho and para position. Now, who are those ortho and para directing groups? Or who are those electron donating groups? That we need to know, right? So it is not the case only with the OH. We do have some other electron donating groups which are called as ortho para directing groups. So that list I will give you, you can take it down. So those are NH2, NHR, NH2 is amine, NHR is again secondary amine, this is amide, and here is your alkoxy, and CH3 is there, it is alkyl, methyl, and this is ethyl, this is your phenol, and if chlorine is substituted, it is chlorobenzene, and this will give you bromobenzene. So all these groups are electron donating groups. Okay, if you find any such groups there in the benzene ring, you can substitute the electrophile in ortho and para position. That's all. Clear for all? Clear? So if I am doing what example? Yeah, if I am doing nitration. Now in nitration, NO2 plus is the electrophile, right? So this is the electrophile in nitration. Now if I have phenol and if I want to do the nitration, in phenol, if I put concentrated HNO3 and if I put concentrated H2SO4, what I have to do? I will get this NO2 plus electrophile from this reaction, right? So that will go and substitute. The ortho and para site of it. Will go and substitute the ortho and para site of it. And in the in class 12 next year, you will study more about this. Okay, you will study more about this phenol and its electrophilic substitution. You will study in alcohols phenols lesson. So there I will discuss about this orthonitrophenol and paranitrophenol in detail with some more explanations. Okay, so now you just study this. If electron donating is there, the electrophile will go to ortho and para. And one more thing also there. We are getting two different products, right? So the ortho product will always be in minor amount and the para will be in the major part. So the major product will always be the para product and the minor product will always be the ortho. So at this point you keep in mind now itself, it will be useful for your other organic chemistry lessons also. Okay. So I hope this ortho para directing group concept is clear to all of you. Am I right? Just tell me yes or no. If it is clear, just type yes in the chat box. We will move on to meta directing groups. Yes. Shall we go? Shall we go with the next thing? Yes. Okay. So coming to the meta directing group, I have taken nitrobenzene as an example for you. So nitrobenzene is taken as an, yeah, okay, Shamila, yes. So nitrobenzene is taken as an example here to understand the meta directing group part. Okay. Now you see, in nitrobenzene, we have 3 electronegative atoms. One is nitrogen and the other 2 are oxygen. All the 3 atoms are more electronegative and oxygen is the second most electronegative element, right? So what is the nature of this electronegative element? They will try to pull the electrons towards themselves, right? What is electronegativity? Tendency to attract the shared pair of electrons towards itself. Now, since we have 3 electronegative atoms in the system, those oxygen atoms and nitrogen atom, they are pulling the electrons towards itself. You see here, oxygen is pulling from nitrogen and nitrogen is taking the electron from the phenyl ring. It is taking from the phenyl ring. So electrons are moving towards the substituent that is attached towards the ring, in the ring. Okay. Now what happens? Oxygen is gaining. So we get the negative charge and this carbon is losing its electron. So it is gaining the positive charge. Now to help this carbon, which is electron deficient in nature, the adjacent carbon is helping. The adjacent carbon is helping with its electron. And this carbon is now going to take the positive charge. Okay. Now to help this carbon, the adjacent carbon will give its electron and it will take the positive charge. Now again to stabilize this, the carbon nitrogen pi bond electron will again come towards the system. We will, the oxygen electron is again coming to the NO bond and we are getting the 5th structure. So what is happening here? The electron density from the phenyl ring is moving towards the nitro group. So what is the, how can we call this group? We can call this group as electron withdrawing group. It is called as electron withdrawing group. Now, if electron withdrawing group is there in the benzene ring, we are getting the positive charge in the ortho and para position. We are getting the positive charge in ortho and para. Electron density is very, very less in ortho and para. Now, if an electrophile want to come and get substituted in the ring, it cannot attack the ortho-para position, right? Because already the ortho-para sites are electron deficient in nature, and electrophile plus will not come and attack the plus part, right? So what happens? They will go to the meta position. Electrophile will go to the meta position and they will get substituted there. Okay. So the electron density on ortho and para position is comparatively less than that at meta, as positive charge appears in the resonating structure in this position. So the electrophile goes to the meta position, which is comparatively more electron rich compared to ortho and para. Okay. So now NO2 group is an electron withdrawing group, and we have discussed the thing with it. And some more electron withdrawing groups are also there. So those are cyanide, CN, CHO, COR. This is nitrobenzene, and this will give you cyanobenzene. This is benzaldehyde, and this is your ketone. We will get acetophenone, and this will give you benzoic acid, and this is the ester. We will get ester, and this is benzene sulfonic acid. So all these groups are electron withdrawing group. If an electron withdrawing group is there in your ring, then the incoming electrophile has to go to the meta position. That's all. Okay. Very easy. You don't have to remember anything. Just study the list alone. Study the ortho-para directing groups and meta-directing groups alone. That is enough. Okay? Is this concept clear to all of you? Yes or no? Just tell me. If it is clear, just tell me. It is clear. Shall we go with the other reactions of benzene? This is the electrophilic substitution reaction, and its related information is clear to all of you. Students, tell me. Yes or no? Am I audible? If you're having any doubt, just raise your hand. Okay. Yes. Okay. So let us move on to the other reactions of benzene. So as I have told you, the addition reactions and oxidation reactions are some of the other reactions of benzene. So first, let us discuss about the addition reaction. Yeah. Under vigorous condition, vigorous means at high temperature and pressure, in presence of nickel catalyst, addition occurs. Addition occurs in benzene. So take the benzene and add 3 moles of hydrogen, because we have 3 pi bonds, right? So we need 3 moles of hydrogen to break and add. In presence of nickel catalyst and on heating, we are getting cyclohexane. So how it is getting formed? You have to break this bond and add hydrogens on both the sides. Break the bond and add hydrogen. Break the bond and add hydrogen. So you will get cyclohexane. All the pi bonds are broken down to give the cyclohexane. Very easy. Same as that of alkenes and alkynes. Okay. Now, instead of this nickel catalyst, if we are using ultraviolet rays, instead of giving this heat energy, if we are providing light energy, if we are providing UV rays, 3 chlorine molecules will get added to the benzene to produce benzene hexachloride of formula C6H6Cl6. So take the benzene and add the 3 moles of chlorine molecule. It is not hydrogen, it is chlorine. Okay, it is like kind of addition of halogen reaction. In alkenes and alkanes, we have discussed the addition of halogens, right? So it is that kind of reaction. So break the bond and add halogens like this. So to all the carbons, 1 chlorine is getting added. So we have C6H6Cl6, which is called as benzene hexachloride, BHC, or gamoxane. It is also called as gamoxane. So these are the two addition reactions. One is the addition of hydrogen and the other one is addition of halogen for benzene. Okay. Here we are giving heat energy and here we are providing ultraviolet rays and then we are heating up to 500 Kelvin. Okay. Now the second reaction of benzene is combustion. Shall I go with the next slide? Did you guys noted it? Shall we go with the combustion? Okay. The combustion reaction of benzene. What is meant by combustion? What is meant by combustion? Already I have discussed combustion with you in the alkanes, right? So what is combustion? Combustion is heating the compound in presence of oxygen. Okay. So when it is heated in air, benzene burns with flame producing carbon dioxide and water. So take the benzene and treat it with 15 by 2 moles of oxygen and it will produce 6 moles of carbon dioxide and 3 moles of water. So when benzene undergoes complete combustion, it will produce carbon dioxide and water. Okay. And the general reaction also I will give you. The general reaction for complete combustion of any hydrocarbon, not only for benzene. Benzene contains C6H6. And if I'm having toluene is this, no, we have C7 and H8. C7, H8 is toluene. It is also a hydrocarbon. And here N value is 7 or X value is 7. So if you're having any hydrocarbon, any aromatic hydrocarbon, if you're having, you have to use this general formula. Okay. If here X value is 7 and Y value is 8, then you have to substitute all those values and X plus Y by 4 moles of oxygen. They will produce X of carbon dioxide and Y by 2 moles of water. So this is a general reaction for any complete combustion. Got it? So these two reactions, addition reactions and combustion reactions, are the other reactions of benzene. And the last very small topic of this lesson is carcinogenicity and toxicity of the aromatic compounds. Okay. So let us discuss that and we will wind up this lesson. Carcinogenicity and toxicity. Carcinogenicity means cancer causing property of this. Now, some of the hydrocarbons are toxic in nature and they are said to possess the cancer producing property. They are very, very dangerous. So some of the examples of those compounds are 1,2-benzanthracene, which contains 4 rings, rings in it. And this is one of the compound and it also contains 4 rings with the 2 methyl group. And here 4 benzene rings and 1 cyclopentane kind of ring is there. And these compounds are said to possess the cancer producing property. So these are nothing but the 2 or more than two benzene rings, if they are fused together, they are producing this cancer causing property. So this kind of compounds are very toxic in nature. Okay. So they are called as polynuclear hydrocarbons. Polynuclear hydrocarbons containing more than 2. 1 ring means it is called as benzene. If you're having 2 rings, it is called as naphthalene. So they are good only. But if you're having more than 2 benzene rings fused together, they are called as polynuclear hydrocarbons. They have this carcinogenicity and toxic property. Okay. Now, how do these compounds are formed? From where we are getting these kinds of more than 2 benzene rings fused together compounds? We are getting it from the incomplete combustion of organic material. Incomplete combustion, if enough amount of oxygen is not required for the combustion of that particular hydrocarbon or that organic material like tobacco, coal and petroleum. So the compounds which I have shown you on the previous slide, such kind of compounds are formed and they are producing this toxic property. Okay. So when they are produced, when they undergo this incomplete combustion and when they are formed in the atmosphere, they enter into the human body. And they undergo various biochemical reaction inside our body. And finally, what they are doing? They are damaging the DNA and they are causing the cancer. Okay, some radicals will be, free radicals will be formed during this biochemical reaction, and finally they cause the cancer. Okay. So you need to be very careful here and just study the name of the compounds alone. Name of the compounds that is given there in your book, that you study and go, and that's it. Okay. So this is the end of the lesson. So hydrocarbons lesson is over here. I think it's already 3:53. So what I will do, I will start the P block elements lesson in the next class. Okay. So today we have discussed the 5 electrophilic reaction, substitution reaction, addition reactions, and combustion reactions of benzene, and the carcinogenicity property of benzene. Okay. So this is enough for today. And I hope more number of PYQs and questions related to hydrocarbons lesson have been solved to you in the weekend classes. Am I right? Saturday, Sunday classes, I think the other teacher might have discussed more number of questions on this topic. You guys also go and study this lesson. It's one of the very important organic lesson. You need to concentrate. Some 3 to 4 questions you can get from this lesson. Okay. So we will discuss the new lesson on Monday. So if you're having any doubt in this lesson from any of the topics that we have discussed, alkanes, alkenes, alkynes, and aromatic hydrocarbons, you can ask me now. I'm here to clear those doubts for you. If you're having any doubt, just let me know. Nobody is having doubt? Okay. Okay then. Thank you so much, students, for listening the lecture. Meet you on Monday. Thank you. Thank you, Hashira. Thank you so much.